Hi all, good day, welcome to the channel. Today we are discussing about Python programming for Bayesian network. You can see the screen for the Bayesian network example, like the cloudy, rain, sprinkler and wet grass. So we are going to keep this and explaining the programming about the query which we are going to ask later, right? Okay, first thing, we are importing the libraries such as Bayesian model, tabular CPD and variable elimination. Here, CPD is a conditional probability distribution. So what this means? Bayesian model used to create a network structure, that is variables and the connections. Tabular CPD, which is used to define the probability of the table. Third one is variable elimination. This is used to perform the inference, that is asking the probability question. So thus that comes under the variable elimination, right? Next one is defining the structure. Model equal to Bayesian model, rain, wet grass, sprinkler and wet grass. Okay, what does this mean actually? This means we create a network with three variables known as rain, sprinkler and a wet grass. Three variables, right? And then the arrow mark means the grass can become wet because of the rain. Another probability is there, the grass can also become wet because of the sprinkler too. So those two probabilities are here. And then conditional probability table. Okay. Now CPD, the probability of rain. So CPD underscore rain equal to tabular CPD, variable equal to rain. Of course, variable car is 2 and the values is 0.7. They're specifying the variable is 0.7. That is probability of rain is 0.7 and 0.3. The probability of rain is 0.3. 0.7 is not rain, maybe. Yes, they given as false. So the probability of rain is not rain is 0.7 and the raining is 0.3. Right? As I said that this defines the probability of rain equal to false is 0.7 and the probability of rain equal to true is 0.3. So 70% change it does not rain, 70% chance it does raining. And then probability of sprinkler, SPD sprinkler, tabular CPD, variable equal to sprinkler, variable card equal to 2 and here values equal to 0.6, 0.4. As I said before, the probability of the sprinkler equal to false is 0.6 and the probability of sprinkler is true is 0.4. That is 60% chances sprinkler is off, 40% chances for sprinkler is on. The next one, the probability of wet grass given sprinkler rain. CPD wet grass, tabular CPD, that is conditional probability distribution, variable equal to wet grass, variable card equal to 2. The values is given in just like in array format, 1, 0.1, 0.2, 0.01 false, 0.0, 0.9, 0.8, 0.99 is true. Evidence is rain and the sprinkler and its car value is 2, 2. So this is most important point. We are defining the probability of wet grass given rain, sprinkler. That means what is the probability that grass is wet depending on the rain and the sprinkler. Okay, in there is 4 cases because of the rain and sprinkler each have a values. One is rain, sprinkler are both false, then the value would be 0.00. And if the rain is false and the sprinkler is true, the value would be 0.9. If the rain is true and the sprinkler is false, the probability would be 0.8. And of course, both our values are true, the probability value is 0.99. That is the thing which they are given. Okay, so if no rain and no sprinkler, the grass not wet. If sprinkler only, 90% will be wet. If rain only, 80% is wet. And if both are true, the 99% will be a wet surface only. Add CPD to the model. So conditional probability distribution, we are adding to the model. Model dot add CPDs, CPD rain, CPD sprinkler, and CPD wet grass. This tells the model here all the probabilities tables and checking models. Assert model dot check model. This checks do probability sum equal to 1 or not. Is everything valid or not? If something is wrong, it shows the error message, and if correct, it continues to execute. Here the inference engine. Okay, inference equal to variable elimination model. This prepares the model to answer probability questions. Think of this as now the model is ready to think. Okay, just ask a question. Result equal to inference dot query variable is rain, evidence wet grass colon 1. This is the question we are asking, and we need to print the result. So we are giving print result statement. This defines probability of rain equal to false is 7.7. Probability of rain is, this means we want the probability of rain given that wet grass equal to true. Wet grass equal to 1 means true. So we are asking what is probability of rain given wet grass equal to true. In simple words, if the grass is wet, how likely is it that it rained? And then we print the result using the printing statement as given below, and we'll something printing like this: P of rain equal to 2, wet grass equal to 2. Then what will be the output? That will be approximately on 0.36% or 36. This means the rain falls given wet grass equal to 2 is 0.36. Then automatically the rain given is true, wet grass true will be 0.64. So if the grass is wet, there is about 64%. There is about 64% chances is rain only. Thank you for watching.